Respected Shri D.S. Chaskar sir, Ankit ji, Saurabh ji, and dear participants, a very good afternoon to all of you. We are going in the fourth week of this program, so I not need to just tell about the program now. You all are familiar with this. But I want to say something that many of you, even the whoever who are here, have also already done. But some of the participants had not even started the modules. So please let them know if they are your friends or your colleagues. Please let them know so that they can start the course, so that they can start the modules. Now, as in the last webinar, some participants requested for the flood forecasting is being done in CWC, that case study that has been taken care of, and now today's webinar is on that topic. So for today's webinar, we have the same faculty which was the last webinar, Shri Ankit ji. So he will take this today's webinar. But before that, I will request our Chief Engineer sir to say the few words to encourage the participants. Over to you, sir.
Thank you, Ashit ji. Good afternoon, everybody, and welcome to this third webinar that we are conducting for as a part of this distance learning program. I'm really happy to see that all the participants who have joined this particular course, most of them are very active. Yes, as said by Ashit ji, some of them are lagging behind, but I'm sure they will also pick up the speed, and they will also be in sync with the weekly activities. Friends, this particular course is a self-learning course. It's very important to understand that we are there to help you. We are there to guide you, support you. But ultimately, it is a course which you have to take yourself. You have to go through the modules once, twice, thrice as it required. You have to do the quizzes. If you get less marks, no issue at all. You can again take the quizzes. We have given 3 attempts to you, and in case of any issue, suppose you are unable to do it in 3 attempts, basically because suppose your attempt got wasted and you submitted the submit button, we are always there to support you. But it is very important that you undertake all the quizzes in a timely manner. This is a certificate course where a hard copy of the certificate, a signed certificate, is going to be issued to you by NWA and by WMO. So it's very important that you complete the activities as scheduled. Okay, complete the modules, complete the assignments, complete the quizzes, and pass the quizzes with appropriate marks. Even if there is a 1 or 2 activity balance, you will not be able to get the certificate. Okay, from our side, we are trying to inform you as to where you in terms of passing of the quizzes which are required to be yet to be taken. So we'll be doing that. But what our suggestion to all of you is that please follow the weekly schedule. Do not lag behind. Okay, otherwise at the end of the day you will have many things to complete. As it happens, in case of a distance learning program, there is always an issue of attention span. Okay, you start something, you leave in between. It's important that you start a module when you are free from other activities. Please do not start the module when you have some other activities going on. You will not be able to complete. You will leave it in between. Again you will have to start it from beginning. Okay, so because this is the 14th course that we are conducting. This is a very enriching course. We have received a very wonderful feedback about the course content and other things. So do take advantage of the modules that have been designed by National Water Academy and also by Comet USA, international level modules. And I must thank Ankit ji that he is now again today with us for taking the case study. And indeed, a case study in a live webinar, it's something which is a very enriching for all of you. We have a one case study as a module, but only if you go through that module as you read along, there might be questions in your mind, there might be doubts, but in this live webinar you are interacting with the faculty who has actually done it. Shri Ankit ji is a very well-known hydrological expert, and I'm sure all of you will take advantage of his presence here. Please do not hesitate to ask questions. Okay, whatever is in your mind, please speak it out. we are there to support you. We are there to answer all your questions. So with this, I welcome Ankit ji and all other participants to this webinar. Thank you. Back to you, Ashish ji.
Thank you very much, sir, for your encouraging words. I hope now the participants who are lagging behind will complete the activities. As sir has told that even a single activity will be left and certificate will not be issued. So all are requested to complete all the activities for the course. I congratulate the persons, the participants who have done the quizzes till now and have scored very good. Even I am seeing that many of the participants have scored 100% marks. So I wish the participants who have not done it or they are doing it, if they have attempted one or two attempts they have taken, they can take one more attempt because you have 3 attempts to improve your score. So with this, I welcome Shri Ankit ji and request him to take the session further. Ankit ji, over to you.
Thank you, Ashish sir. Respected Chaskar sir, thank you for the kind words. And Saurav and all the participants. Today's session, it will be on flood forecasting and the activities done by CWC. It's not a lecture, it is not linked with the DL program, but it is what actually is done by me or by my division in field. We'll try to cover like what all things with respect to flood forecasting and flood related activities are done in any divisions of Central Water Commission. We'll talk about what is done by my division in Bangalore, and thereafter we'll try to compare with respect to in the monsoon season of 2024, what was the status with respect to flood forecasting, and that will be a kind of case study. Any questions with respect to that, I'll welcome even in between or at the end of the session. With permission, I'll just share the presentation.
Yes, Ankit ji, you can share it.
Thank you. I hope it is visible.
It's visible.
Okay, thank you. Sorry. Okay, as we all know, floods are very common, especially in a country like ours. It's a very commonly occurring natural disaster which occurs almost every year in some parts of the country. One of the measures of mitigating and managing floods is through structural measures. Let's say we have a river, it is prone to getting floods. We may have structures on that river. These structures can act as a barrier to store the excess amount of water being carried by the river, which may avoid floods downstream of that structure. But again, these structural measures are only preventive up to a particular extent. Maybe smaller floods and medium floods can be managed through structures, but very high floods are not very effectively managed by a structure. Further, in case the flood magnitude is significantly high, it always has a risk of that structure getting failed. And in an event of failure of a structure, in event of a dam break, the resulting catastrophe is going to be huge. So managing of floods using these structures is a means, and it is also used, but it is not a very effective means, both in terms of cost and in terms of effectively managing the disaster. In addition, the climatic changes, what climate is suggesting is there are more frequent, higher critical events which are coming with respect to whatever was happening in the past. Again, that is also posing a kind of challenge to us. Flood forecasting is a non-structural measure that flood forecasting is one of the non-structural measures in which just by having information on what type of flood is expected, we can help in mitigating it, we can help in managing it. And again, if at all, let's say a flood is going to come and authorities are warned maybe in advance, maybe 24 hours, maybe 72 hours, maybe whatever advance warning can be given, lot of damage can be avoided. Lot of damage in terms of property, in terms of lives, lot of lives can be saved if at all effective and like coherent like measures are taken in terms of warning as well as mitigatory actions. Now, there are two things. One is flood comes in and like the water enters into the villages. This is the time when a warning such as the like river is not having that much amount of capacity and the water which is coming in the river is higher than the capacity. If that type of warning is given, adequate like mitigatory actions with respect to like district or state can be taken, can be initiated, and people can be evacuated, livestock can be evacuated, lot of damage can be like reduced. Secondly, if at all we give an advance warning saying that this much amount of flood is going to come in some of the structures, let's say in a dam, effective management or effective operations of the dam can be done, and that anticipated amount of flow which is expected in the dam can be better managed. And again, we have already covered that peninsular India faces much more like hydrometeorological damages because of atmospheric phenomena such as depression and cyclones. And some part of southern India, mostly Tamil Nadu, faces both the monsoons, that is southwest as well as northeast. So, okay, in terms of forecasting, CWC does two types of forecast. The first one is level forecast. Let's say we have a river. In the river, there's a particular area, there's a particular reach which is vulnerable to floods. Now, what CWC does is it gives a level forecasting that what is the level that is expected in next 24 hours in that particular river stretch. Now, there are means to do it, but advantage which this particular like level forecasting has is, let's say a river which does not have a capacity beyond a particular amount of discharge, adequate measures can be taken if at all water is going to like cross the river boundaries and get inundation is going to occur in the villages. It's an important type of forecast. What we give is what is going to be the level in the river after 24 hours from the date of issue of that forecast. Let's say I'm issuing it today. The forecast will contain that what is the likely water level that can come in next 24 hours. It is important in flood prone reaches, and it is important to place these reaches in places which are vulnerable to floods. Let's say we have some villages, we have some cities, just upstream of those villages and cities and these important areas, we can have a level forecasting site. And these level forecasting sites can give us a timely warning of what is going to be the level or what is going to be the like floods in that particular reach in the next coming hours. The second type of forecasting is inflow forecasting, in which we predict how much amount of water is going to come inside a reservoir, maybe 6 hours, 12 hours, or 24 hours, or even greater than that in future. Now, what advantage this happens is it helps in better managing the reservoirs, mostly in lean season or mostly in like water stressed areas. It is very important to ensure that good amount of storage is there in the reservoir by the end of monsoon season, or by the starting of summer season, good amount of water should be there in that reservoir. But it has to be like taken into account that if at all a major flood comes in, we are better equipped to discharge that flood so that no danger happens, no like critical situation happens for that particular dam. Now, okay, the level of water, which is the volume of water which is going to come in the next, let's say 12 hours or 24 hours, if that information is there with the dam authorities, the dam regulators, they can better and effectively like take decision of how much amount of water to be given out. The important point is, in most of the time, by the end of monsoon season, maybe in the month of August, September, October, November, most of the reservoirs are mostly full. They are full up till FRL, and they like most of the dam authorities, they would like the water to remain at that FRL or whatever is the maximum level in that particular reservoir. And this is the time when sometimes critical rainfall event occurs. And if at all timely information comes in that this much amount of flood is expected in the next 24 hours or next 12 hours, adequate measures can be taken, more amount of release can be initiated at the beginning itself, at the like time when the flood has not started coming in, so that buffer can be created and more amount of flood can be stored, lesser amount of damage can happen in the downstream. Now these two type of forecastings are done by CWC. We'll try to talk about what is done in our segment. If we talk about like level forecasting, CWC maintains some level sites, and at these level sites, what is done is we keep on monitoring what is the water level on an hourly basis during the entire monsoon season. So for Kaveri division in like Bangalore, most of her sites have monsoon season from 1st of June to 31st of December. So for these 7 months, every day, every hour, water level is taken and it is being recorded and transmitted to us in division office. We further disseminate it to stakeholders for taking like necessary action. Now in level forecasting, we divide the river section into n number of sections, or let's say the overall depth of the river, we divide it into whatever is the safe depth, whatever is the depth after which there's a danger to like public, danger to mankind, danger to the villages, and there's a like highest flood level that is there in the rivers. Our objective is before the river comes to the village, at an upstream point, we should give an information that this is a water level which is critical, and this critical level can endanger the village downstream. So at a point upstream of the critical area, we predict how much amount, or we monitor and we also predict how much amount of flood is like anticipated in the next 12 to 24 hours. Inflow forecasting is how much amount of water is coming into the reservoirs. We already talked about it. Now, as per SOP of Central Water Commission, during the flood season, during the monsoon season, for different parts of the country, we have notified different monsoons for different areas. Most of the sites in Kaveri and like lower Krishna region, the Tungabhadra and middle Krishna region, we have monsoon defined from 1st of June to end of December, 1st of June to 31st of December. Now, during this particular span, at every hour, we keep on checking how much amount of water level has been attained in that river. Now, based on water level which has come in and based on whatever is the amount of precipitation which has either realized or predicted in the upstream catchments, we somehow predict and say that in the next 24 hours or next 12 hours or next 6 hours, this is the amount of water level that is expected. Now, based on this warning, we categorize it whether that volume, whatever the water is coming, that is a safe flood, that is a warning level flood, or above level flood. It's a severe
Nikki, your voice is disconnected, I think.
So am I audible now?
Yeah, now you're audible.
Okay, thank you. Okay, let's say we have a river. Now this river channel has some capacity to take in floods. This channel has some capacity to hold floods. Now, whatever is the water level in this particular level, we categorize it in terms of these levels. Normally we say that there's one level known as danger level. I'll just come to this thing. Sorry. Yeah. Okay. Now we have defined one particular level in a river saying that this level is danger level. This is our understanding saying that if at all water level rises above this level is going to inundate the downstream villages or inundate the area of like concentration that is like just downstream of this particular point, which is of importance to us. This warning level or danger level is very important because if at all water level exceeds this particular level, there is going to be some amount of damage in the downstream reaches. Highest flood level is the maximum level that the river has reached in the historical like data set which is available with us. Let's say we talk about a particular river. That river may be in any particular year, 1960s, 1970s, 1980s, whatever maximum level it has shown, it has like the maximum level that has been observed, that we call it as highest flood level. We define a danger level. This is that level after which, if at all the water level rises, it is going to create some amount of damage in the downstream. And there's another level, warning level, that we have defined, which says that if at all warning is given at this particular level, adequate mitigatory action can be taken till the time the water level reaches the danger level. That means danger level is that particular level at which the river is not having the capacity to discharge that much amount of water, and whatever amount of flood is being carried by the river is going to inundate the villages. Warning level is that level which is lower to the danger level, which says that if at all warning is given at this particular time, we'll be getting enough amount of time, maybe 6 to 8 hours or maybe 12 hours, to evacuate or to take mitigatory action in that village so that damage can be minimized. Now the question arises, how do we fix these three levels? Now this highest flood level is effectively fixed by the historical records. We have a site at that particular location from last 50 years. We just find out in last 50 years what is the maximum level that the river has attained. That level becomes the highest flood level. That is something which is fixed with respect to the years of historical record available with the office. Danger level is normally fixed by the district authorities or state authorities, which is relevant to a particular area or which is relevant to a particular site, saying that beyond this the water enters the villages. There can be some sites, there can be some locations in which even if the capacity of river exceeds, even then the danger level doesn't exceed, because there's no danger to the nearby villages even if that capacity gets breached, even if the water comes into the floodplain areas. And again, whatever this level is, that is being fixed by the district administration and values are being given to us. Warning level is normally fixed by us and validated by the state authorities, saying that as per the past record, normally from warning level, from this level which has been decided to reaching that like danger level, roughly around 6 to 8 hours are required, or even if 3 to 6 hours are available, we sometimes fix the warning levels. Again, it depends on like what type of river it is. Let's say we talk about a big river like Ganga or Brahmaputra, taking like even increasing in 1 centimeter or let's say 10 centimeters of water level, it takes a huge amount of time. It takes a huge amount of water to increase the water level by a centimeter or by like 10 centimeters. Reason being, the width of the river is very huge. It stretches across kilometers. And for increasing the depth by a few centimeters, it requires a very huge amount of discharge. And again, moving from warning level to danger level may take a huge amount of time even for a small distance. So that like the amount of like level between the warning level and the danger level may be lesser in case of larger rivers. Whereas a river which is flashy in nature, or rivers which are there in hilly states, or maybe the rivers which are there in southern states, normally the rise in water level with respect to like discharge is quite huge. Even with few cubics of increment in the discharge, the water level may rise by a few meters sometimes. So in that particular case, we can even keep the warning level maybe a couple of meters.
Angijit, it is again paused.
Am I audible now?
Yeah, now audible.
Okay, now whenever we are observing the water level, we categorize it. Am I audible?
Yes, Ankit, you are audible.
Okay, sir, thank you. Okay, whenever we are observing the water levels, we give it that what is the stage in terms of this categorization, whether it is within the normal like, capacity of that particular river, whether it is above normal, whether it is there in severe condition, or whether it is in extreme condition. And based on the categorization, appropriate action can be taken. and it is like a red color. Just like moving out of it, there can be a situation when the flood in the river is flowing in the extreme condition, but it is not damaging the villages. It may so happen that, like, not with respect to our country, but there can be a hypothetical situation in which there's no village along that particular stretch of the river. In that case, even if the water level is exceeding the highest recorded flood level in that particular plain, again, it is not endangering the population or endangering the livelihood nearby. Okay. There's a app by Central Water Commission, which is known as Flood Watch app. At the time of flood, you can on live, you can see what is the situation of rivers at any point in the river, wherever we have a flood forecasting station. This is one of the representation for one of the sites in Kaveri division. It is a terminal site in Kaveri before it enters Tamil Nadu. And it was taken when the water level was much below the warning level. If at all it rises up, it will come in various zones, and whatever the color is, the same color will get represented in that particular site. Now, how does this danger level is fixed? Again, it has been it should be provided by the district or state administration based on what is the situation of floods, or what is the level of flood at which it endangers the nearby, let's say, crops or villages or bridges or property or life. That particular level is the danger level. And again, this danger level needs to be verified on a routine basis. This danger level may change. Let's say we have fixed a danger level now. After 5 years, the situation may change. That village may move out of that particular area, or that village may encroach the floodplains furthermore, such that even a lower level attained may endanger that particular village. So again, we need to continuously revising the flood levels and danger levels, and again, decommissioning of embankments and sediments and erosions, and river profiling, change in river geology, that also affects the danger level. Talking about what is done by us in Kaveri division, coming to the case study part. This is what is the jurisdiction of Monitoring South Organization, Central Water Commission, Bangalore. We are maintaining a total of 47 HO sites, 47 discharge sites effectively. It is being done by 4 subdivisions. We have a subdivision in Bangalore that takes care of the upper Kaveri portion. We have a total of 24 HO sites in this particular region. Then we have a upper Tungabhadra subdivision. Krishna Basin, that is Malaprabha, Ghataprabha. We maintain some HO sites on these particular rivers. And we have 4 HO sites on the west flowing rivers that drain in the Arabian Sea, 2 in the state of Goa, 2 in the state of Maharashtra. There's just an overview of what the jurisdiction looks like. In addition to HO sites, we maintain a total of 20 meteorological stations. This is manual meteorological in
Ankit, there is some connection issue, I hope.
Yes, I think there is a connection issue. We will wait for some time so that Ankit ji comes back online again.
So it is audible.
Everybody's. Yeah. Now it is audible. Now you are visible also. For some time there was a break. फिर से आपका डिस्कनेक्ट हो गया है शायद.
Am I audible? Hello.
Yeah, but presentation is not visible. You just shared and that again.
Yeah, is it visible now?
Yes, now it is visible.
Okay, thank you. When he talked about the metrological like distribution within MSO, like was it audible then, or should I repeat this particular slide?
No, it was audio earlier.
Okay, fine. So we have a total of around 20 meteorological stations that we manually observe, and we have a total of 32 telemetry stations, which
Ankit, it's again the connection issue.
so it's audible to me. It's like, is the presentation visible?
Now it's all visible.
Okay, sir. Thank you.
Sir, maybe you can switch off your video, then maybe the connection will work fine.
Just give me a minute.
Just try.
Sure, sir. Just a minute. I hope this works.
Yeah, now it's working. Let's
Okay.
hope it works.
Sure, sir. Now, as far as the current arrangement prevails, in Kaveri division, we don't have any level sites. The main reason may be because there are no like much flood instances or flood situations within Karnataka or jurisdiction in Goa or Maharashtra. That is why as of now, we are not maintaining any level sites, but we are maintaining 8 inflow forecast stations. Inflow forecast is normally there at a reservoir. So we have a total of 8 reservoirs in which we are predicting and issuing inflow forecast for these 8 reservoirs. 4 reservoirs are there in Kaveri Basin, Kabini, Krishnaraja Sagar, Harangi, and Hemavati. 2 are there in Tungabhadra Basin, that is Bhadra Dam and Upper Tunga Dam. And 2 are there in middle Krishna. One is Malaprabha Dam on Malaprabha River and Hidkal Dam on Ghataprabha River. We'll talk about it. Now in inflow forecasting, the volume or discharge that is anticipated in next 12, 24 or 48 hours is assessed. Forecasts are formulated in the division office and they are issued to all the stakeholders so that like whatever operating action needs to be taken gets taken. Now, again, we don't issue these forecasts on a daily basis. We are like assessing the information that how much amount of flood is coming in, but we forecast or we issue the forecast only when the amount of anticipated forecasted value exceeds a particular threshold. Now, under normal circumstances, some amount of flood is going to come and enter into the reservoirs. Only when this amount of flood which is entering exceeds a particular threshold, it becomes important for the like dam authorities for taking like necessary actions, or otherwise whatever rule curves are, they prevail under normal circumstances. In journal, we say that flood for such huge amount of reservoir. In that case, the threshold can be increased by project authorities. There can be a reservoir which is very small or which is very like, what do you call? It is sensitive to the floods. Even a small amount of flood changes the water level significantly, something like a gauge type of reservoir. In such type of reservoirs, even this threshold can be reduced. It can be made it to 75 or 50 cumecs. In our case, 2 of the reservoirs, one is Upper Tunga and Hemavati, they have in writing given to us that take the threshold as 150 cumecs. Again, for Bhadra Dam, there's again a different value has been defined. The threshold value which has been defined as 400 cumex up till the level in the reservoir reaches a particular level. In this case, it is 162 feet, and it changes to 200 cumex for the storage above 162 feet. Now, what is the significance of this? When the reservoir is empty, there's no much need of advance warning, because whatever amount of flood comes in, there's a huge amount of buffer to store that volume of flood. But once a particular level in that reservoir exceeds, once the level increases a particular level, that is the time when it is important for the flood, like dam authorities, to know how much amount of flood is going to come in next hour, or maybe next 6 hours, or maybe next 12 hours, so that appropriate decision can be taken in terms of release of water from the dams. Again, such type of action has been taken by Bhadra Dam. They have defined the threshold. They want us to issue the flood forecast whenever the flood increases 400 cumex till the time the level in that reservoir is 162 feet. Once the level exceeds 162 feet, they want us to issue forecast even at 200 cumex or larger. For remaining 5 dams which are being maintained by division, Kaveri division, we don't have any recommendation from the project authorities. And in that case, we are adopting the basic SOP of CWC, that whenever the inflow flood expected is more than 100 cumex, we start issuing the flood forecast, or we start intimating them that this is going to come. The assessment is done on a daily basis. Under normal schedule, normal circumstances, flood forecasts are issued our prediction, our analysis say that further more flood can come in, or significantly lesser flood is expected based on the rainfall which has realized upstream. We can even change, or we can also issue special advisories. These special advisories further guide the project authorities to take appropriate decision. Sometimes it happens that we have issued a forecast and suddenly some landslide occurs, or suddenly some significant amount of critical rainfall event occurs. In that case, we again issue some advisories. Advisories are also issued in some unnormal circumstances of dam break, embankment breach, some information on some critical value of floods coming in. We keep on doing such kind of things. We also issue special advisories if at all the reservoir level is beyond or is exceeding the FRL capacity. It is just at FRL capacity and rain is happening upstream. In that circumstances also the special advisories are issued. Okay, now talking about how exactly is the flood forecasted, or how is that flood forecast assessed by the division office. Now for doing that, there are some methods. One of them is gauge to gauge correlation. Now let's say we have a particular forecast station. We want to forecast the level at a particular point. Let's say this is the river, and this is the point of importance to us. This is the point where we want to find out how much amount of flood is coming in. Normally we have a base station upstream. This base station is that reference point which gives us information on how much amount of flood has been observed at this particular point. Now whatever flood has been observed at this place, by knowing the hydrology of this particular region, by knowing how much is the travel time of this flood for reaching to our flood forecast sites, and also having information on how much amount of rainfall has occurred in the intervening catchment, we can predict how much amount of flood is going to come, or how much amount of flood is coming at this particular point. Now the simple flood moving from one end to another end, just by gauge to gauge correlation, by just finding out what is the relation between discharge observed at this point and discharge observed at this point, we can have some idea of how much amount of level can come in. Let's say I have an important flood forecast site over here. This is the point which is critical to me. I want to forecast
आई थिंक ये फिर से डिस्कनेक्ट हो चुका है. जस्ट वेट, एवरीबडी प्लीज स्टैंड बाय. अंकित जी के कंप्यूटर में कुछ इश्यू लग रहा है. जस्ट होल्ड ऑन. शायद उनके नेट कनेक्टिविटी में थोड़े इश्यूज है.
Participants, please hold on. We will be back. Don't leave the meeting.
There seems to be some issue in the faculty's internet connectivity. Kindly hold on. He will be back within a minute.
So am I audible now?
Yes, Ankit, you are audible now.
So actually, I don't know why, but it was visible to me. I could hear you. I could see
Okay.
you, but my voice was not coming through, I guess.
Yeah, and your screen was also, PPT was also not visible. But no issue, we can start again.
Is it audible now? Is it visible now?
Yes, it is
audible,
visible.
But your voice is a little bit slow. Less.
शायद वो आपको माइक्रोफोन लगाना होगा कान पे प्रॉब्ली. आपका माइक्रोफोन कहाँ पर है?
Is it audible now?
हाँ, it is perfect now. It is perfect.
Okay. Thanks, sir. Thank you. We were talking about gauge to gauge correlation. Was it like audible? Do I need to like repeat it? I'll just repeat a small part of it. We have a river. We have a point of interest. This is the point where we want to forecast or we want to like predict how much amount of flood is going to come. Normally, we maintain something known as a base station upstream of the river. Whatever is the observed value of discharge at the base station, that helps us in predicting how much amount of flood is going to be observed at the forecast station. Now, whatever forecasting is to be done, it is to be done for future, let's say 12 hours or 24 hours in future. And normally the travel time from base station to our like forecast station, it should be more than 6 hours. But in some of the cases, we even get more than 24 hours. So greater the lead time, better it is for forecasting. So if at all we have some information of base station and we know how much time it takes for that water to reach our point of interest, and we know how much amount of rainfall has happened in the intervening catchment, taking some like correlation of gauge to gauge as well as some addition because of the rainfall in the intervening catchment, we can predict how much amount of rain is coming or how much amount of discharge is coming over here. What we do is we create a simple rainfall runoff model and we add in some information of the base station so that the like whatever the discharge is, it gets refined. So the most crude or the most like conventional approach of assessing the flood is gauge to gauge correlation. We find out a station upstream of our flood station and we correlate what is the relation between the discharge at the two stations. If the discharge at the upstream station is increasing, it is likely that the discharge at the forecasting site is also going to increase with a lag time of whatever is the lag between the base station and the forecasting station. This is the most crude and the most like high approach. The second one is mathematical or an empirical relationship in which we correlate the level of discharge at interest. Am I audible?
Yes, MKG, you're audible.
Okay, sir, thank you. Okay, we can have a simple mathematical relationship between the stage or water level, stage or discharge at the forecasting site with respect to upstream stage or discharge, or we can have a relationship with respect to rainfall. These are mostly empirical models developed based on experience for a particular site, but again, they also give a good relation, or they also act as a good tool for predicting what is going to happen in future. Let's say we have a forecasted value of rainfall. We can have a journal mathematical equation. We can calibrate an equation saying that if at all this much amount of rainfall comes in and this is the upstream discharge, we put in that particular equation. That equation is a function of upstream discharge as well as rainfall. And what we get is the predicted value of discharge that is anticipated at the forecast station. Again, that is a good approach followed sometimes, but we need a good amount of data. We need people having good experience of that particular site for developing these relationships. Another one is something which is more relevant to the ongoing course, that is unit catchment response function. That is, we develop a unit hydrograph. We try to find out how much amount of rainfall has come in. Based on rainfall, we convolute the unit hydrograph. We get the amount of hydrograph that is anticipated downstream. We can also route this from one station to another station so that we get the attenuation, we get the travel time. We know how much amount of flood can be expected at the forecast station or at the reservoir, so that necessary action can be taken. Another one is a rainfall runoff model. We can develop any rainfall runoff model. It can be based on the rational approach, CIA. Coefficient can be based on the antecedent moisture conditions of that particular catchment during that point of time. We can have a lumped model. We can have a lumped model created, something like a unit catchment response function. We can create it in a complicated tool, something like Mike. We can create it in something like HSE. We have a lot of tools available. We calibrate the model, how much amount of rainfall gives how much amount of runoff. We take the predicted rainfall from IMD. Using the predicted rainfall and our understanding of hydrology, we convert it into discharge. This discharge is the value which we disseminate to the stakeholders for taking mitigatory actions. We can also use a complicated hydrodynamic model, which is nothing but solving of Navier-Stokes equation with certain assumptions. And using the same, we can run a real-time analysis. The most reliable thing which is required in a forecast for any of these techniques is reliable rainfall forecast. Now, whenever we are saying that we are dependent on rainfall for conversion of rainfall to runoff using a RR model, our input as rainfall should be reliable for giving a reliable output as discharge. If at all we are not taking reliable input or reliable rainfall as input, our output is not going to be that reliable. As far as our division is considered, IMD helps us a lot. There's a flood monitoring organization of IMD in Bangalore that is instrumental in providing meteorological inputs on a real-time basis, or they provide it twice in a day. They provide it once when we require it, maybe at 11:30, 12 o'clock in the morning. They again revise it at 3 o'clock, 3:30 p.m. And based on their forecasted input of rainfall, we forecast how much amount of flood can be expected in the 8 reservoirs wherein we are predicting the rainfall, predicting the inflow forecast. Normally, what IMD provides is a 7-day quantitative precipitation forecast. That is, in next 7 days, what is anticipated. What they provide is tomorrow, in next 24 hours, what is the expected value of rainfall? In 48 hours, what is the expected value? In every day, consecutive days, how much amount of rainfall is anticipated? That is what IMD provides. And whatever information is given, mostly for bigger catchments, it's very reliable information. Only for smaller catchments, the catchments which are there in hilly domains, which are there in upper reach of both Krishna as well as Kaveri, the information is sometimes not relevant or sometimes not reliable for getting it materialized for forecast. Again, the time of issue of our forecast is directly dependent on the time on the receipt of meteorological inputs. like as per mandate, we are supposed to issue the forecast at around 12 o'clock. But sometimes even the rainfall input, we don't get it by 12. We get it by, let's say, 1:30. In that case, we issue the forecast. We issue the forecast after calibrating our models, after running our models, and we give it maybe half an hour to 1 hour after the receipt of rainfall information. And again, sometimes IMD revises its forecast at 3 p.m. based on if at all there's a significant change in the next 24 hours, because what we do is 24 hours forecast for the reservoirs. If at all there's a significant change in 24 hours rainfall, we again change our forecast based on the revised rainfall input. And meanwhile, our office is there in constant touch with the dam authorities. Whatever queries they have, whatever deviations they are going to make, they are there in touch with us before based on the forecast and based on the anticipated values in future. Once based on the discussion only, they take the decision. Okay, now for what we do. Before going through this, I'll just talk about, just a minute. Is Google Earth visible on screen?
Yes, it is visible.
Okay, sir, thank you. Okay, this is the subcontinent of India. The portion in red is something which is jurisdiction of Monitoring South organization that is being managed by Kaveri division over here. We have a total of 8 reservoirs that we are forecasting. 4 are there in Kaveri basin. The first one, which is Kabini, it is there in Kabini River. Kabini River is one of the tributaries of Kaveri. It meets Kaveri at some place by name T. Narsipura, and thereafter it goes to Tamil Nadu. This is where it enters into Tamil Nadu. Now there's a dam over here, Kabini, and we are mandated to forecast flood for this particular reservoir. We have one base station by name Muttankera at this particular point. We get information from Muttankera, and we have a total of 4 telemetry stations upstream. Based on the information of telemetry rainfall, based on the input of IMD, and based on the discharge observed at Muttankera, we assess using some of the correlation equations. We assess how much amount of flood is anticipated in Kabini Dam, and this is how we forecast for this particular dam. We have one station upstream. Talking about the other one, that is KRS, it's a bit tricky over here. This is Krishna Raja Sagar Dam. It's a huge dam, more than I guess 100 years old. Just upstream of this, this is there on mainstem Kaveri, but just upstream there are 2 tributaries which are joining Kaveri. One is Lakshman Tirtha, which is joining from the south, and there's Hemavati, which is joining from the north. And this is the mainstem Kaveri, which is coming from upstream. Now, based for predicting how much amount of water is anticipated in KRS Dam, we need to have information on all three of these rivers. Now, for all these 3 rivers, we have some stations which are very critical for its prediction. One is Akhiabal on Hemavati River, Chunchunkate on mainstem Kaveri, and KM Wadi on Lakshman Tirtha. Again, for most of these, all these 3 stations have a travel time of around 8 to 12 hours for reaching KRS. For Lakshman Tirtha, we don't have any other station other than KM Wadi. So whatever information comes in, that needs to be adopted for while assessing or while finding out how much will be the contribution of Lakshman Tirtha in KRS. Whereas for Kaveri, we have 4 HO sites upstream of Chunchunkate, and one of them having a travel time of around 18 hours is Kudige, and this gives a very critical information of how much can be expected at Chunchunkate itself. And once we have information of what is the level that can be anticipated at Chunchunkate based on the flood which has been reported at Kudige, a better forecast can be made for KRS, which is being contributed by Kaveri River. Similarly, for Akhiabal or for Himavati, we have around 5 stations upstream. And again, from MH Halli to Akhiabal, we have a travel time of more than 12 hours. Using this information, again, a better prediction can be made for KRS Dam. And again, whatever forecasts are being made, it is very much into an accurate zone because of like good amount of hydrological network. We have another dam, which is Harangi. It's on Harangi River, again a tributary of Kaveri. This is mainstem Kaveri. Kudige is there on mainstem Kaveri, and this is a small tributary adding and joining over here. We have a dam by name Harangi at this particular location, and we have an upstream station by name Murkudlu. Issue with this is, though, like firstly, the travel time from Mukudlu to Harangi is quite less. It's less than 6 hours. The reason being like the distance is quite huge, but entire like catchment is hilly in nature. The slope of catchment is quite huge. Because of huge slope, whatever water gets like precipitated within the catchment, within a short span of time, it reaches Harangi Dam. And that is the reason we don't get like enough buffer time to give a prediction beforehand. And that is why Harangi's prediction is not very good. Again, the reason is we have a very short stretch of river as Harangi, and the travel time from the base station to Harangi Dam is less than 6 hours. But at least we have a base station, and using this base station, we make the prediction. We correlate how much amount of like discharge flowing through this is going to come over here. And though we are measuring discharge once a day, we are measuring the water level throughout the day, every hour. And we have like for these base stations, we keep on calibrating these stage discharge relationships on a frequent basis so that this doesn't give us a bad forecast. So whatever is the discharge which is observed over here, that is correlated to how much amount of discharge is anticipated at Harangi and issued. Similarly, in Kaveri, we have another dam, which is Hemavati Dam. Again, Hemavati Dam is like at a location of confluence of two rivers. One is mainstem, like Hemavati. Hemavati is again a tributary to Kaveri, meeting at KRS Dam. And another river, which is known as Yagachi. We have good amount of like stations on both the rivers. These stations, Beta Damne and Sakleshwar, give input of how much amount of water is coming in the mainstem Hemavati, whereas Belur and Thiminahalli, they mainly provide how much amount of water is going to come in the Yagachi River. Janapura is a station being maintained on another like tributary to Yagachi River. Again, this also provides some amount of input, but whatever is the input of Belur and Janapura gets captured at Thiminahalli, and mostly Thiminahalli is used for predicting how much amount of water is going to come at Hemavati. These were the 4 dams in Kaveri Basin. Moving on to Tungabhadra, we are doing forecast for 2 dams. One is Bhadra Dam, and one is, this location is wrong. The location is over here. This is like Upper Tunga project, also known as Gajanur Dam. This is on Tunga River. This is on Bhadra River. Now, the challenge in Bhadra is we don't have any base station upstream. These 3 stations that you are seeing, they are just potential sites. Just 3 months back, in the month of January, the competent authority in Central Water Commission has approved one site on this river upstream, that is Balehanur site. These locations were the potential locations proposed by us for like shifting the, or like for opening a HO site so that it can act as a base station for Bhadra Dam. Ultimately, the Balehanur site has been approved as the station, and this has a travel time of around 6 hours. So in future, whatever prediction we are doing for Bhadra, it will have some base station, it will have some information on how much amount of discharge is there at the top. As of now, in the past, whatever forecasts are being issued for Bhadra Dam, they are purely based on rainfall runoff modeling without any information on what is the actual flood upstream of the river, because entire river was not gauged up till now. Even now, it is not gauged, but we have gotten approval for establishing site at Balehanur, and maybe before the monsoon of 2025, we'll be establishing this particular site. Work is under progress. Again, because we don't have any station upstream of Bhadra Dam, and we are purely relying on the rainfall information. And again, rainfall is, because this entire reach is a hilly reach, whatever rainfall occurs within a few hours, it reaches the dam. Because of these constraints, not having a base station and the travel time of rainfall being less, normally the accuracy for this dam is not very good. Talking about UTP, this is the project that is, this is the location of UTP dam. So for this, we have a couple of stations upstream. We have a total of 3 stations. Kalmane and Mahishi are mainly on Tunga River, and these two provide a good information on whatever amount of forecast is going to come at this particular point. But again, Tunga is on a hilly range. Entire like catchment is a hilly slope. The travel time from the upstream, even Hariharapura to this place, will be somewhere around 8 to 9 hours. So though we have base station upstream, but it is not giving us a good lead time for giving a better forecast, and we need to revise forecast on a very frequent basis. Moving further up, we have 2 more stations, 2 more inflow forecast stations. One is Malaprabha Dam on Malaprabha River and Hidkal Dam on Ghataprabha River. Again, we don't have any base stations on any of these 2 rivers. But still, whatever rainfall is getting predicted for these 2 stations, it's not very bad. Plus, the catchment is not very hilly for these 2 dams. So we get a good amount of travel time. We get a good amount of lead time. Hidkal, not very much, but Malaprabha, we are in a position to give good amount of forecasts. Again, we have proposals of establishing 2 telemetry stations, both on Malaprabha as well as Ghataprabha rivers. That means 2 on Malaprabha river and 2 on Hidkal river. That will act as a base station and forecasting sites for Malaprabha as well as Hidkal projects. This is overall what we do and how we do in terms of forecasting. I'll just get back to the presentations. Okay, is the PPT visible? Ashish sir?
Yes, it is visible.
Okay, sir, thank you. Okay, now we are more interested in what is the basin-wise or sub-basin wise rainfall which is coming within the catchment, so that whatever, we have already studied about lumped models, semi-distributed models, and distributed models. We had talked about that lumped models lump the entire properties throughout the basin wise. It lumps the properties, which is not very efficient, not very good type of model. Distributed model is data it requires a huge amount of data for forecasting. Again, that much amount of data in a real-time basis may not be available at all the regions. So we prefer quasi-distributed models. And to analyze quasi-distributed models, whatever input is being provided by IMD to us, that is again as a quasi-distributed manner. They provide us information sub-basin wise. Let's say we want to forecast for Harangi. Whatever forecast of rainfall is being provided by IMD is only for that Harangi sub-basin. Further, we have a couple of telemetry stations within Harangi catchment, which again support and validate the information that whatever information is being provided by IMD, that gives us a second confidence that whatever we are doing is correct. We go ahead and issue the forecast. Similarly, Hemavati is a separate catchment, Kabini is a separate catchment, and entire Kaveri, the upper Kaveri for KRS, the entire Kaveri, we are getting aggregated values also. So we have different sub-basins, sub-basin wise rainfall parameters we are getting, rainfall values we are getting, and these values are normally adopted for forecasting purposes. Again, for Krishna Basin also, whatever IMD provides is sub-basin wise rainfall. We have Benehalla, which is again a tributary of Malaprabha, Ghataprabha, Krishna, Middle Tungabhadra, Upper Tungabhadra. We get different amount of rainfalls, and again we use this subdivision wise rainfall for predicting or assessing our forecast. Whatever forecast is issued by us, again, that forecast contains some values, like it provides the weather information. Whatever information is provided by IMD, we try to provide that information in the bulletin, saying that this much amount of rainfall is anticipated in the catchment. We also try to provide the forecasted maps. IMD provides us some maps saying that this much amount of forecasted rainfall or forecasted weather is anticipated in that subcatchment. Subcatchment wise, we also provide that this is the anticipated location of rainfall that is anticipated in your subbasin. Then we also talk about the realized precipitation, how much precipitation has occurred. We provide what is the water level in that particular reach, whatever water level is there in all the flood forecasting sites maintained by Central Water Commission. And we given the forecast. Like in our case, we provide how much amount of anticipated value is expected in the reservoirs. And sometimes, if at all, some breach of embankment, some dam break is also like anticipated, we also provide that as a subnote to it. Okay. Just a brief of what is done by us. In division office, we maintain a modeling center. We call it as divisional flood control room and modeling center. And it is operational on a 24/7 basis for the entire monsoon period. That means for 7 months on a 24/7 basis, one room is operational, who are actually simulating most of the models. They're getting information from site officers, and based on the information from site officers and simulated results from the models, they issue forecasts. Normally forecasts are issued once in a day, that is maybe 12 p.m. or 1 p.m. in the afternoon. But sometimes when the critical events are coming in, when the water level in any particular site is exceeding the danger level, or let's say some sudden amount of flash flood is expected in a particular reservoir, even flood forecasts are issued during night times. Water level is being recorded on an hourly basis. Rainfall of meteorological stations maintained by us are being recorded on a 3-hourly basis. And from sites and subdivision itself, these information are being recorded on the WIMS portal. And they are also being shared to us through email and WhatsApp. Again, we analyze the information, we just scrutinize it so that it gets at least primarily validated. And primarily validated information is further disseminated to the project authorities or the stakeholders, disaster management, district authorities, and whomsoever is interested in our data, we share the data to those organizations. Daily, we issue flood advisories and flood bulletin. And in case of extreme events, we also give special advisories or special bulletins. Whenever the water level exceeds danger level, or even if it is nearing the danger level, we issue special advisories. Whenever very heavy rainfall is predicted by IMD, we again issue special advisories. Normally this happens, again, IMD also issues special advisories to intimate that in a certain location, extreme flood or extreme rainfall is anticipated. Based on their anticipation, we also run our models, and we also give that based on their input, more amount of flood is expected. And again, this is in the form of special advisories. Whenever it is crossing HFL, we even report it to higher authorities so that the information can be updated. Information on dam break, flash floods, inundation is also included. If the state authorities demand, even water level information, stage discharge curve, telemetry based rainfall, that is also being shared by us. And most of the information is updated on the WIMS portal, which can be downloaded by even the state authorities. We have already talked about it. We have 8 reservoirs for which inflow forecasting is being done. 4 are there in Kaveri Basin, 4 are there in Krishna Basin. In 3 of the dams, Malaprabha, Hitkal, and Bhadra, we don't have any base station. Whereas for the other, like for KRS, all the 3 rivers, we have some upstream stations. For all stations, at least one station is there. For Bhadra, we have one Balehanur, which is yet to be commissioned. But most probably by this monsoon season, this station will get commissioned. And maybe in a couple of years, we'll be refining our models for this particular station so that better forecast can be issued. As far as evaluation of forecasts are considered, we make some forecasts for 24 hours. And whatever is the forecasted information, our forecast is compared with whatever is the actual observed after 24 hours. And as per norms of CWC, for level forecasting, if the level, whatever has been forecasted, is within 15 centimeters of actual observed, we say that the forecast is good, it is reliable, it is within the acceptable range. If at all it exceeds the 15 centimeters gap, we say that it has failed or it needs further refinement, or that particular forecast has particularly failed that time. In case of inflow forecast, we predict some amount of inflow coming into the reservoir. Again, some buffer is given if at all the actual observed is within 20% of the forecasted value. We say that it is within the acceptable range. If at all it exceeds 20%, we say that it has failed. Again, this is not sacrosanct, even if there can be some like justified reasons wherein the floods or wherein the forecasted values exceed observed values. That may be because of some contributions which are not through the basic rainfall runoff modeling. It may be because of dam break, it may be because of GLOF, it may be because of any other particular reasons. If the overall accuracy of Central Water Commission's division is less than 80%, then justification may be required. Otherwise, if at all it is more than 80%, we keep on refining it so that better accuracy can be like given. For the monsoon of 2024, I have just put in one particular date, that the date on which the maximum flood has been observed. On that day, what was the forecast issued by us? Because this is the most critical time. Normally, when the flood is not very high, when some amount of inflow is anticipated, which is greater than the threshold limit, normally the 20% barrier is achieved. 20% threshold is achieved. Because whatever amount of rainfall is coming in, it is based on whatever base station you are considering. Based on that discharge or based on whatever rainfall has occurred, based on our equation, most of the time it gives relevant values. But during extreme values, during extreme floods, when the maximum flow has been observed, that is the time when model mostly fails. And those dates in which the maximum flood has been observed within the Kaveri division, these values have been noted. Let's say for Harangi, the inflow forecasted by us on 1907 was 440 cubics, whereas on this was valid for 24 hours. On 27, the maximum which was observed was 468. Because the deviation was 6%, we call it as it is within the acceptable range. And even if we have provided a forecast of 440 cubics, whatever has come has given some idea to the dam authority for regulation of that particular reservoir. In one of the cases, that is Bhadra Dam, our forecast was 1000 cubics, whereas the actual observed was 1728 cubics. We have even investigated why this happened, and most of the cases, because in Bhadra we did not have any base station, and the rainfall prediction which was given by IMD was somewhere around 10 centimeters, actually realized was 17 centimeters. Because there was a huge amount of variation, there was a gap in the observed outflow also. And again, it crossed the barrier and we call it as the forecast failed during that particular time. Okay. There's one more slide, I guess. This is the last one. This is the overall performance of the division. For KRS Dam, total of 143 forecasts were issued during the monsoon season, out of which 136 were there within the acceptable range, giving an accuracy of 95.1%, so on and so forth. Total of so many forecasts were issued, so many were in acceptable range, giving various different values of accuracy. Okay. There are various measures that can be taken to improve the accuracy. One is we are using both correlation as well as the Mike model. Sometimes correlation and Mike model do not give good results, and we rely on one of the two. If at all we refine the model further, we fine tune the model further, and we give both the techniques give us a similar amount of value, it will give us more confidence in issuing discharges, and even the discharge will be much more reliable. We don't have base station for 3 stations. Effectively, that is also going to get like reduced in a couple of years. Travel time between like one of the stations in Harangi is less than 5 hours, which is again less and can be improved. Sometimes even the information provided in terms of actual realized inflow is not authentic in one sense, and that also may add to inaccuracies or inconsistencies. Again, optimum threshold also needs to be fixed. Sharing of information is also critical. Lead time is a critical value, critical parameter in forecasting. If at all we have good lead time, forecasts are going to be better. If at all lead time is 5 hours, 6 hours, the forecast for 24 hours are not going to make much sense. Again, we have limited staff. That is another reason. That was all from my end. Thank you. Any questions? Please let me know.
Participants are requested to ask questions, queries, doubts, if they have any. You can unmute yourself and you can speak, or you can type the question in the chat box. Please unmute yourself and speak. Anybody would like to ask any question?
Sir, good evening, sir.
Good evening.
Sir, just now in the slides, you said that for Bhadra, you got the percentage deviation is only 42%. The variation is much. But however, in the next slide, for the Krishna basin, you have shown Bhadra for 92% accuracy.
Yes. Okay, so I'll just answer to that. See, in a particular event, let's say I'm forecasting today for tomorrow. I forecasted today, I predicted something is going to come tomorrow, and one day it failed. Count it as
अंकित, आपका वॉइस ब्रेक हुआ है. You are not audible, Ankit. I think probably you got disconnected. Please hold on. I think there is again some issue with the end of the faculty. Please hold on for a minute. There are questions also coming in the chat box. I would request all of you to please stand by.
hello.
So the faculty will be online again. Please wait, and he will answer all your questions. This session is basically giving you the practical experiences of flood forecasting, okay, which you may not get insight of when you go through the modules. Okay, he had shown you number of forecasting stations where forecast is being given by the Kaveri division, and what criteria is being used, how the forecast is formulated, what is the lead time available, what are the different considerations that are being taken into account while issuing the forecast. All these aspects are very important and critical aspects, which you may not find in a written modules.
Am I audible, sir, now?
Yeah, you are audible. Please go ahead.
So I'll just answer to that question for Bhadra Dam. Now, let's say I am issuing one forecast. I have issued a forecast today. That forecast is valid till tomorrow, and that forecast significantly failed. I predicted for 1,000, 17,000 came in. That forecast failed. But during the monsoon season, a total of 100 forecasts were made. Now, out of 100 forecasts, more than 85 forecasts, or maybe 95 forecasts, whatever was the percentage in that slide, that many forecasts were successful. Some forecasts were failures. Getting my point?
Okay, sir, got it.
So that will be the difference. The number of forecasts, maybe 95% must be in accurate state, but some of the forecasts would have failed and they must have been failed by a marginal value.
Okay, however, you said that is a peak flow. That
Sorry?
is a,
Sorry, come again.
for peak flow, we are not getting accurate results. That's what.
Normally, this is my experience also. Whenever we are talking about very high floods, under these very high flood circumstances, our forecasts are not within the acceptable ranges. During like somewhat moderate, somewhat less than the very high peaks, we are getting good results. But even the slide which I showed, these were the maximum floods that has the maximum flood volumes that have been received by the dam authorities, by the which has been observed. Even for them, out of 8, only 1 has failed. Remaining have been like within the acceptable range.
Ankit, there has been a few questions
So,
in the chat box.
I'll
Question.
read the question, sir. I'll read the question and answer.
Yeah, sure. Go. The first question is from Nishant
Yes, sir.
Galpati.
Nishant Galrapati, he's asking, is there any selection criteria for positioning a base station? Yes, sir. What we do is, whenever we are setting up a base station, our primary criteria is we should get sufficient amount of base time, lead time for making a accurate amount of prediction. Now, in some of the cases, if at all we are getting like 12 hours or greater, that is a very good base station. But sometimes we don't get something like Bhadra. We evaluated 4-5 stations. We evaluated 4-5 potential sites, and we like convoluted it to 3 sites which were giving us good results. These were potential sites wherein we could have opened our site. And ultimately, when other parameters were also examined, whether we have a straight reach or not, whether it is single channel, whether it is showing some like deviation in the past, when we consider all the parameters, we find out that one site, that is Balehanur, it is giving us a potential site where we can open a hydrological observation site. And again, we checked out how much lead time it is giving. It was giving us somewhere around 6 to 7 hours. And considering that 6 to 7 hours is like minimum required, we have opened that particular site. But greater lead time available is better for opening a site, a base station. I hope I have clarified this particular query. I'll move to the next one. Sir, what is the minimum amount of data required to develop rule curves? Rule curves is a separate domain. Rule curve is a guiding curve for the dam regulating authorities to intimate how much amount of water to be stored or how much amount of water to be retained within the system and how much amount of water to be released. Now, this is a function of 2 different criteria.
I think we lost the audio again. Just for a moment, please hold on. There are very nice questions being asked by the participants, and we will have answers to all the questions. Just please hold on.
So am I audible now?
Now you are again audible. Yeah, please go ahead.
Okay, so I'll continue to that particular thing. The minimum amount of data required for developing rule curves. I was mentioning that rule curves are guiding curves to a dam regulating authority, which guides them to like how much amount of water in the reservoir and how much amount of water to be released by them. Now it depends on 2 like basic parameters. First is what is the time of the year, whether it is early monsoon or end of the monsoon. And second criteria that governs this is how much amount of inflow is coming in. Because at the end of the monsoon, if at all huge amount of inflow is coming in, the regulation or the release from the reservoir is going to be a function of how much amount of inflow is coming in. Now, this rule curve development is a separate domain in itself, which analyzes the historical availability of water in different times of the year and the significant critical events that occur in that particular river system in the past historical times. Let's say we talk a particular river, that river shows a particular type of hydrograph throughout the year. During June, there's a certain amount of flow at a particular dependability. Till the time of December, it varies. Again, that particular river system shows significant critical events during the late end of the season. Let's say during November, December, there's a huge amount of critical events coming in. In that case, rule curve has to take into account and keep some amount of buffer available with the dam so that if at all a critical event comes in, the dam is capable of handling that particular situation. I hope I have clarified this particular thing. This question. I'll move on to the next one. Kindly write again if at all there's any missing link to my answer or if there's a follow-up question to that. Sir, how frequently we need to revise the rule curve for an existing reservoir? Again, it depends on what is the change happening to the hydrology of that particular catchment. If at all hydrology is not much changing, if at all our outcomes from the dams are not much changing, we may not require to change the rule curves. But in general, what happens is the hydrology upstream of the dam, it frequently changes. The land use changes, the pattern of discharge generation, it changes. Even because of climatic changes, the pattern of water which is coming to the reservoir, it changes. Because of all these reasons, and because even the need of operation changes based on the requirement of water downstream. So we need to change it on a frequent interval. 5 to 10 years may be considered as reasonable time. One guideline has been formulated by DRIP, as far as I know. They have mentioned some criteria of frequency on which it is to be revised. Normally, it is to be reviewed in 5 years and revised in 10 years. If I'm not wrong, you can go through it for a better dates or better timelines. Sir, can you elaborate more about the FloodWatch app? Now, this is a app developed. This has been developed by Central Water Commission. I think Chaska sir was instrumental or was a part of it, if I recall. I'm not knowing about the background of it, but this app is it is linked to the WIMS portal. Whatever information is being entered by any of the divisions within Central Water Commission, and whatever forecasts are being made, and whatever the actual observed values of discharge, actual flood levels observed at different beaches, that is getting displayed in a graphical manner in this particular app. One can download this app through Google or Apple mode, go through any particular river reach, any particular station maintained by Central Water Commission. On clicking it, we get to know the hydrograph on how the water level is changing in that particular thing. So, would you like to add?
Yeah, you have covered perfectly well. Actually, CWC has a website, flood forecasting website, and also website for advisory forecast of 7 days. Okay, so the advisory forecast as well as the forecast issued by the divisions in real time, they all are available through this web app actually. So the app is basically a front end for displaying the same information which otherwise is available on the respective website. Okay, so this app is very user friendly, which shows very readily the information about your nearby area, so that as a citizen you are aware what is happening around. But yes, you can see the information about any other area in the country also.
Thank you, sir. So I'll move to the next question. What are the institutional arrangements made with the dam authorities to regulate the reservoir operation in the event of flood crossing danger level? Now, all the divisions, we are having some stakeholders before.
I think we lost the audio again. Just wait for some time. Where we are really having very good questions.
Is it?
Yeah. Now it is back. Yeah, please go ahead. Some issue in the internet, it seems. Some issue in the bandwidth.
I'll switch off the video if it works.
Yeah. Now it is working. Yeah, I think probably you can keep the video off.
Yes, I have switched off.
Yeah.
Actually, this institutional arrangement is made by the regional office with all the concerned stakeholders within that jurisdiction. Like in Kaveri division, we have a close connect with all the 8 dam authorities. we have a meeting before the flood begins, before the monsoon begins. We have we exchange the phone numbers, and our office, like divisional flood control room, is there in constant touch, maybe on a daily basis or a weekly basis, with all these dam authorities. Even if it is raining, sometimes when my office is unable to get in touch with them, even dam authorities contact me. So there's a whomsoever is forecasting, whichever division is forecasting, they're in close touch with the dam authorities, and they keep on asking before even releasing some releasing the water, sometimes in the fag end of the monsoon season. I hope I have tried
I
to.
would just also like to add a small
Sir.
thing. A division is normally given responsibility of predicting or giving the forecast of certain inflow forecast for certain dams and level forecast for certain stations. So in case of inflow forecast for dams, the forecasts are shared with the dam authorities at different levels. Okay, they operate or they take the decision to operate the reservoir based on the forecast given by CWC. Okay, the CWC forecast acts as a reference for them to operate it, but ultimately the operation of the reservoir is totally the responsibility of the dam authorities. Okay, we give them the input, but we don't have any control, or we cannot direct them to do the operation as per our kind of understanding. It is up to the state authorities, it is up to the dam authorities to operate the reservoir. Sometimes we do give advisory. Okay, we do issue advisory to the dam authorities. Yeah, say for example, we issue that we are issuing this forecast, but we anticipated more rains in the upstream area, and we request you to, or we advise you to create a cushion in the dam by releasing more amount of water. That kind of advisory we give, but ultimate decision to operate the reservoir lies with the dam authorities. That is what I want to convey.
Thank you, sir.
Yeah, please go ahead.
Okay, sir. The next one is, what are your suggestions for issuing flood forecast in hilly states like Himachal Pradesh? Now, this is a common issue in any of the hilly areas, even the Arunachal, even in Uttarakhand, even in the upper reaches of Krishna Kaveri. If at all we are forecasting without a base station, our information on rainfall has to be very concrete. If at all we have good reliable information on rainfall, our predictions can be of reliable values. But if at all we have a base station and travel time is less than 3 hours, 4 hours, 5 hours, it is not making much sense, because till the time we are issuing forecast, the flooding has actually started. So it doesn't make much sense if at all we don't have good base or good lead time from the base station. But if at all we have good information on rainfall, that can help us in creating a better RR model. Using that better reliable input and a good RR model, we can have some amount of forecast. That may not be very much helpful, but it will be at least somewhat helpful. It will give us some information or some time to take mitigatory action. The next one is, if lead time is 6 hours and the reservoir gets full, what is the impact of lead time, as it will be less than 6 hours? So the question is not very clear to me, but what I mean to say is, we are getting information from a base station which is 6 hours away, but rainfall prediction we are getting 24 hours in advance, or maybe 7 days in advance. Based on both whatever has occurred in the past, whatever is the observed discharge of having a lead time of 6 hours, and based on the rainfall which has occurred or which is going to happen, predicted rainfall in the next 24 hours, predictions are made. And again, if at all lead time is less than 6 hours, whatever the forecast is, it's not very much reliable, but whatever information is, it gives us at least some cushion to the dam authorities for regulating the reservoir. I'll move to the next one, sir. So for an optimal reservoir operation during extremes, how can we correlate the rule curves with discharge, stage discharge relation?
You are not audible, Ankit. I think we lost your audio again. Ankit. Okay, till we get back, Mr. Ankit, I will try to answer this question. How can we correlate the rule curves with the stage discharge relation? Now, these two things are different, you know. Rule curve, as Ankit ji told you, is basically for the operation of the reservoir. Whereas stage relation is a stage discharge relation is basically for a river channel, you know, that at what stage, what is the discharge. Say, for example, for a base station, we may have a stage discharge relation, and depending upon the stage, we can make it out that this much discharge is now coming, and with a lead time of say 7 hours, 8 hours, we can inform to the project authorities that within this much of time, this much of amount of water is reaching the dam. So there is no relation between the rule curves and the stage discharge curve. No, both are different entities. Rule curves basically gives you that up to a certain date in a reservoir, how much water level, maximum water level should be. Say, for example, in case of August, what should be the maximum water level in the reservoir? In September, what can be the maximum level? In October, what can be the maximum level? So the water level in the dam, maximum water level that we can maintain in the dam, or the reservoir level that we can maintain, is related to the time frame. That is a rule curve. Whereas stage discharge relation is basically for a HO site in a river where there is a relationship between the water level and the corresponding discharge. Hope I'm clear. Ankit, have you joined
Yes,
back?
sir. Sir, am I audible now?
Yeah, you're audible. Yeah. Go ahead.
Sir.
Yeah.
Thank you, sir. You have wonderfully answered that question. I'll move to the next one, sir.
Yeah, sure.
Sir.
Sure.
So the next one is, how can we identify the factors contributing to inaccuracies in inflow forecasting models, considering potential sources such as model structure, spatial distribution of gauges, and other influencing variables? Okay, Mr. Nishant, what we do is, let's say we have made some forecast and that forecast has failed. Like in the case of Bhadra, we forecast just 1000 and actually observed was somewhere around 1500. Sorry, 1700 something. So after this thing has occurred, after this thing has failed, we try to investigate what was the reason. And we try to find out whether it was the model that failed to give us a right prediction, or whether it was the faulty parameters that were entered as input. Now, in this particular case, as I mentioned, that there was some factors like the prediction which was given by IMD was 10 centimeters, but the actually which was realized was somewhere around 17, 18 centimeters. And that was one of the reasons. Again, if at all we find out that the rainfall, whatever we had taken, was correct, and that was the actual rainfall that has been realized, but still our forecast has been deviating. Like in one of the cases, we were trying to calibrate a particular model, and this thing happened. We tried to give rainfall, and whatever rainfall we used to get a deviated values of runoff, deviated values of forecast. And we identified that the model needs to be further fine-tuned, it needs to be further calibrated. And again, it was calibrated for another 6 months, and thereafter it started giving a better results. Like one of the stations which we are working in, we are trying to set up a level station. During the monsoon of 2023, we were getting an accuracy of around 27%. During the monsoon of 2024, we have got an accuracy of around 76%. Again, it is getting refined. So we keep on identifying what are the reasons. If at all reasons are there in our control to modify, we try to fine tune the model and try to get better predictions.
I would also like to add to this, Ankit.
Yes, sir.
When we have a model, forecasting model, the input for the forecasting models comes from the point rainfall. You know, we have a gauge stations, and we measure the rainfall in the upper catchment area through telemetry or through our manual gauges, and we enter it into the model. So it is kind of a point value, but which gets applied to a more larger area while when the model does the computations. And nowadays we know that there can be very large variation in the rainfall pattern, and you may not capture the high rainfall events. suppose a high rainfall event occurs between the two rainfall stations, so it doesn't get captured, because the rainfall is not recorded in the both the stations. Only when that discharge appears in the base station, then it comes to we come to know that yes, some rainfall has occurred, heavy rainfall has occurred, and it has got we have a higher discharge. So understanding the spatial and temporal variation of the rainfall is one of the factor which causes inaccuracies in the inflow forecasting models. Okay, so how can we have a better understanding of spatial as well as temporal variation in the rainfall pattern? Obviously, you need to have a very high density of the rain gauges and very frequent measurements. The other data which is very useful in understanding this issue is the radar products. In India, we do not have yet a very dense radar coverage. Radar coverage gives you the spatial distribution of the rainfall, okay, and also the temporal distribution. So it gives you a very clear picture as to how at what location how much rainfall is occurring and for how much duration. Okay, those radar products have been IMD has started publishing those radar products, but they have not yet been very well established. Unlike other countries like Japan is fully covered with the radars at a very close density, and their radar products give you the complete rainfall pattern in a very detailed way. That is one part of it. The other part where we can know about the inaccuracies is the ungauged catchment areas. There are many catchment areas where we don't have any gauging network, and sometimes we get surprises from such areas. So there are various ways and means by which you can understand as to why the forecasting model is not giving accurate results, and over a period of time, with your experience, with your intuition, you can and with the calibration efforts, the efforts of fine tuning the things, we can arrive at a fairly good accurate model of the forecasting. So you can go ahead, Ankit.
Thank you, sir. It was really knowledgeable. जो आपने बताया बहुत अच्छा था. I'll come to the next one, sir. Can we expect rely on any remote sensing methodology for crucial insights in flood forecasting during extremes? So based on my experience, based on my understanding, all the remote sensing inputs, that is the satellite inputs, they are very good in giving us relative values of rainfall, but in absolute terms they somehow dodge the bullet, they deviate a bit. And if at all we have reliable remote sensing estimates, we can go ahead and use it for forecasting. But for the time, as per my understanding, the absolute values of the rainfall inputs, they are not very much reliable, and that is why we are not using it as of now. But in future, if at all we get good reliable values in terms of absolute terms, we can use it in forecasting approach.
Yes, that was a very nice question actually. There is a one stream of remote sensing technology which is getting developed, is a microwave remote sensing. Microwave remote sensing is having an ability to penetrate the cloud cover and go below. It also has because of its ability to cover to penetrate the cloud cover, it can also find out some of the properties of the cloud cover, which can give you an idea about the potential rainfall or happening rainfall as well. Okay, because remote sensing basically works on the principle of images taken by the cameras, by the sensors in certain spectrum. Okay, now visible spectrum cannot pass through the cloud cover. You won't be able to see anything below the cloud. The only spectrum which can pass through the cloud cover is a microwave sensor, and that's why nowadays microwave remote sensing is getting popular in understanding the potential of rainfall on the basis of imagery taken by those by in that spectrum. Also, the depth of the water-bearing clouds. There are various ways and means by which we can make out that even it can give you the rainfall also, how much rainfall is happening. The science is under development. Our own ministry, because this particular sensor is specifically useful only for the rainfall and water resources, this particular sensor has been sponsored by our Mantralaya on the INSAT satellite. So we have contributed to this sensor basically because we wanted to use it. And last year we conducted one program specifically in National Water Academy as to how to analyze the microwave remote sensed images to understand the rainfall prediction as well as the ongoing rainfall. So this particular question again is very important in the sense that there are two ways of finding out spatial and temporal distribution of the rainfall as it is happening in real time. One, by radar. Okay, so radar is on the ground, so it can scan the area below the cloud where the rainfall is occurring actually. Okay, and the other way is from the top, from the satellite, from the top of the cloud, and that is possible with microwave remote sensing. But both the things are not yet developed to a stage where we can directly use it in analysis. It is in the developing stage. Our IMD is working on it. Our NRSA is also working on the microwave remote sensing. There is a space application center, SSC Ahmedabad. They are also working because most of the faculty that we invited for the microwave remote sensing was from SSC Hyderabad. So this is a very pertinent question. In the coming days, in the coming years, we will have more and more studies on this aspect. In fact, one of the module of our distance learning program, one of the module is exactly on this one: how to leverage remote sensing, microwave remote sensing particularly, in understanding the inputs for our flood forecasting. Thank you. You can continue, Ankit.
Thank you, sir. Again, very knowledgeable, very insightful. We have established the GD site and operated for 4 to 5 years continuously. But then during a particular high flood event, the cross-section changed significantly. How do you tackle such problems in CWC? So I'll just talk about what we do in our setup, our division. We are concerned with like 8-9 HO sites which are actually like contributing to flood forecasting, which are base stations or like forecasting stations for getting inputs to the inflow forecast. Now what we do is, let's say it is like the geology is changing frequently, the morphology is changing, and the cross section is changing frequently. But let's say in a particular monsoon year, we keep on like getting both like concurrent results, concurrent like values of stage and discharges. Every year, whenever we are forecasting, let's say this year, we keep on developing this stage discharge curve during the monsoon itself. Today we have seen a discharge. Today we have like correlated with a stage. We have marked it on a stage discharge curve, and we keep on doing it in the same monsoon itself. Even when the monsoon, the cross section is changing, our stage discharge curve is getting refined. And if at all like we are predicting or we are forecasting for a particular day, the precedence, like some of the days, some of the like values of stage discharge, they help in forecasting or they help in like extrapolating the stage discharge curve. And this is how we are tackling the, like if at all there's a change in morphology or change in geology of the cross section of the like river. Any input, sir? Should I move forward?
Yeah, please go ahead. Please go ahead.
If RF runoff regression is developed for a sub-basin, can we rely on the discharge value with respect to observed rainfall at particular location? Can we adopt the proportionate discharge for a stream within the sub-basin? It's developed for a sub-basin. I'll just try to like convey what I have understood through this. What I have understood is, for a sub-basin, rainfall runoff regression model has been created. Rainfall runoff model is a model which is helping us to convert rainfall to runoff using a linear or non-linear relationship between the rainfall and runoff. Now, can we adopt the similar, like based on proportionate method for a stream within the subcatchment? As per my understanding, if the catchments, both the sub-basin as well as the like within that reach wherever we are like geographically transposing the model, if both the catchments are homogeneous in nature, having similar type of land use pattern, similar type of soil, similar type of like basin characteristics, we can transpose it, we can take it and put it within that, inside that catchment. But if at all the heterogeneity is there, if at all the upper reaches are hilly, lower reaches are like planar regions, or if at all the upper reaches are having like rocky soil, lower reaches are having like sandy soils, it may be like difficult to transpose. But in other cases, if at all the catchments are homogeneous, it can be transposed. So these are the questions which have been posed in the chat box.
Yes, any other question? In fact, it was a very enlightening discussion. Very nice questions were asked by the participants. Any other question? If you want to give any remark, say something about your experience, you can always unmute yourself and speak.
Sir, good evening,
Yeah.
sir.
Yeah.
Yes, sir, the question I asked that question, sir, regarding the rainfall runoff regression. Sir, if in most of the rivers in our country, we have developed the regression equations we are already having. So, can we adopt the same for ungauged streams? Because we are for ungauged streams, they are there to find out the discharge, etc. So, can we adopt that regression equation for that and arrive the discharge value? It may not be 100%, but
I'll answer that, sir. Okay. So as I just said, if the two catchments, one is ungauged catchment, one is gauged catchment, if both the catchments are homogeneous in nature, homogeneous in terms of catchment geographical properties, if the catchment slope, the land use pattern, the soil pattern, the overall characteristics of the catchment, they are more or less similar, then one model developed on a gauged catchment can be transposed to an ungauged catchment. The same model which has been developed for a gauged catchment, that model can be regression model, that can be a distributed model, that can be a mic model. Same can be transposed to an ungauged catchment and we can estimate the discharge in that catchment. But if at all there's a heterogeneity between the two, in one catchment you have a city, in another catchment you have a forested area, then it cannot be transposed.
Yes, or for example, if one catchment is a hilly area and one catchment is a plain area, then probably you will not be able to use it.
thank you.
Any other question by any participant? Well, we had a wonderful webinar today. Particularly the questions were really insightful and their answers were very enlightening. So on behalf of National Water Academy and on behalf of all the participants of this training program, I thank Shri Ankit Dudeja ji for taking this second webinar also so nicely. And he will be available throughout the program duration to answer any of your queries. Please post your queries through the course forum. There is a WhatsApp group also, but we would prefer that you ask questions through course forum so that everybody else also gets to know about it. So we will have another webinar. We are planning to have another webinar when we go to the slightly advanced topics, because this particular week is having slightly advanced topic. You have yet to undertake those modules. We are planning to have one webinar from Shri N.K. Mathur Sahab, a very senior officer of Central Water Commission, a expert in hydrology, and we will get some insight from you. Maybe next week we will schedule that webinar. One small correction from my side: I said that the microwave remote sensing module is part of this program. No, this is not part of this program. It is a part of the advanced version, okay, which we are going to conduct later on in this year. All the officers who are successfully completed basic distance learning program will be eligible to participate in the advanced program. And in the advanced program, we have those that module on microwave remote sensing. So again, I would request all the participants to complete the activities as per the schedule and be ready for the next webinar. We will announce it in WhatsApp group. We will also announce it in course forum. So in the end, I once again thank Shri Ankit ji for delivering such a nice webinar, such an enriching webinar for all of us. Thank you.
Thank you, sir. Thanks a lot.
Thank
you, sir. Bye.